with closed-loop fuel control requires a technician to determine if the source of the trouble is electronic or mechanical. This is typically accomplished using artificial enrichment or propane and enleanment vacuum leak. However, with OBD2, the fuel control and O2 monitors can isolate the problem automatically. In this section, we'll focus on the operation of the fuel control monitor. This is where the fuel trim comes into the picture. Fuel trim is an adaptive control strategy used by the PCM for adjusting pre-programmed injector pulse width. Short-term fuel trim, or STFT, allows for temporary mixture adjustments in closed loop and serves as the basis for long-term fuel trim, or LTFT, corrections. For example, if the mixture is biased lean due to an air leak, STFT will compensate for the imbalance by adding fuel or increasing injector pulse width. Fuel will continue to be added until the proper air-fuel ratio is restored or STFT reaches the limit of its control. LTFT values are stored in cells, each of which represents a particular combination of engine speed and load. As the engine operates within the parameters of a given cell, fuel delivery, or injector pulse width, will be based on that particular LTFT value.
Fuel trim is displayed on the scan tool as a percentage. These valves are based on the input signals from the upstream oxygen sensor or sensors in closed loop. 0% indicates that the mixture is balanced and no adjustment is required to the pre-programmed injector pulse width. A negative percentage is an indication that the PCM is reducing injector pulse width to compensate for a rich exhaust, while a positive percentage means that fuel is being added to compensate for a lean exhaust. The adaptive values for STFT are erased when the ignition is turned off. In contrast, LTFT values are stored in the computer's memory and remain there until the PCM's memory is reset with a scan tool or continuous battery power is removed from the PCM. With a properly functioning engine in closed loop, STFT will typically fluctuate within a narrow range of plus or minus 3%. On V-type engines, the scan tool will display fuel trim according to cylinder bank, i.e. STFT1, STFT2, LTFT1, and LTFT2. Keep in mind that the adaptive control limits for fuel trim vary among PCM manufacturers. For example, on some PCM controllers, the LTFT may have control within a range of minus 35% to plus 35%, while on another PCM controller, the LTFT will operate within a range of only minus 23% to plus 16%. These inconsistencies between PCM controller manufacturers also apply to STFT control. As the engine operates within the parameters of a given cell, fuel delivery will be based on that particular LTFT value. When STFT attempts to correct a mixture imbalance, LTFT will observe the short-term adjustment and gradually move in the same direction. If STFT is able to restore the mixture to the stoichiometric level, then LTFT will update the fuel delivery value for the appropriate cell or cells, and STFT will be reset.
The fuel control monitor analyzes the activity of short-term and long-term fuel trim on a continuous basis, making it a continuous monitor. If STFT and LTFT remain at their limits too long, as would be the case with a severe air leak, for example, the fuel control monitor will fail. If the monitor fails on 2 consecutive trips, the PCM will illuminate the MIL and store a hard DTC.